Alright everybody, we're about to finally start bringing in the web servers into web development this week. So this week we're going to talk a little bit about what HTTP is, how websites work from a server perspective, and we'll kind of set the tone for the rest of the course going forward. So the first thing we should talk about is the web in general, and just kind of how browsers fit in, and the web as you know it, and the web as what's actually going on. So whenever you load up a web page, the only thing that's really going on is that your browser is doing something called making an HTTP request on your behalf. And what that means, it sounds all fancy, but what that means is that your browser is configuring in a standardized format a series of lines of text that gets sent off to a server, and then the server parses, interprets it, runs through it, and figures out what it needs to do in order to give a response back. It's all just a series of messages back and forth. It's a very long handshake. And that's all that happens in the web. When you load up google.com and you get a web page as the home page, that's just because Google sent back a response to you that had a bunch of text that so happened to be in the HTML format with some headers set up saying that it's going to be an HTML document so that your browser can then read it, interpret it, and build out the Google homepage. And that's all that's going on with the web that you have to worry about for the sake of this course. You're going to be making requests, you're going to be receiving responses. You'll be writing servers that render responses. They'll interpret requests rather, use data that is stored in the request, and do some action accordingly. So you, as a web developer, are just trying to make this communication possible. Now, the request is always formatted in the same way. There's always a couple of things to them. There's always an HTTP verb. Now, a verb signifies what type of action you want to commit with that request, whether you want to retrieve data, create data on a server, update data, or delete data, or is there some other fancier ones nowadays. You also will always have the server that you want to point to and send that request to, which is known as the host. And you want to send the location, which is the actual resource location that you want to send. So if you were to have http://google.com /search for question mark search for query equals Stevens Institute of Technology, you would have the location or the path being /Steven search for Stevens Institute, and so on. And you also are going to include headers. Now, headers are just metadata about your request. Cookies are sent in headers. Authentication token is very often sent in headers and stuff like that. So headers are very useful, but you won't be configuring them too deeply for this course. Now, when the request hits the server runs through the request and interprets it. And when we say interprets it, we mean it looks at the location, it looks at the data inside of it, and it determines what happens. Now, some servers like Apache have a whole set of rules and a whole set of modules to add functionality where it essentially looks for a file name or rewrites the request to point to a file. We won't be doing anything like that because our server will just be a programmed Node application itself. So we're going to download a Node package called Express, and we're going to configure what happens at different locations through Express. Now, we'll be doing that by setting up routes. Now, every time you do set up or send a request, you will receive a request, you'll be sending some sort of response because otherwise you'd never know if the action was completed, you'd never get the information you requested or whatnot unless we sent a response. So when you write a server for the rest of the course, your goal is interpret a request and send off a response accordingly. If we were requesting information about a blog, a request would be for a post, and our response would contain the post. Now, there are many other types of responses we can send. We can send just raw information through JSON objects, or we could send files. We can send pictures, movies, images, plain text, and so on and so forth. So these requests, at the end of the day, you just need to view them as content you send down. Usually it's text of some sort. Now, while you send down text of some sort or content of some sort, you also send down metadata of your own. Now, you'll be sending down some information such as headers that set whether or not cookies get set on the client side, for example. You also send, very importantly, a status code. Now, this status code will tell the browser or the user's HTTP client, whether the request was successfully interpreted and responded to, whether there was some sort of redirection, whether there was an error made on the client, such as a bad URL, or whether there was some error on the server. And you'll be using these different status codes accordingly. Now I just want to stress one more time, there are many different browsers, but all they do is allow a user to navigate to a URL and send a request and receive and interpret a response as best they can. So it might be useful to not view web servers as something that sends down web pages, but rather that web servers are just little applications that transmit information in response to a request. So you're going to always think from now on in terms of setting up one request and figuring out what to do with one type of request and figure out what sort of response has to be sent. You are not sending pages. You are not making a website to show people pages. You're making web app pages and websites rather. You're making websites and web applications to send information down to the user. Now we're going to finally start using something called JSON a lot. JSON means JavaScript Object Notation, and it's a very popular way of representing data. It's not typed, it's very slim. It looks just like an object in JavaScript. However, many different programming languages can parse it and use it accordingly so that it can be kind of a go-between. Now, since you'll be writing JavaScript on the front end and JavaScript on the back end, it's incredibly useful to use these JSON objects because you'll be able to just request JSON from your server. Your server will be able to easily send down JSON. And then you'll be able to use those objects in your JavaScript on your client side so you can update it accordingly. So with that being said, we're finally going to take a look at our first server. And if you look at these lines that I've highlighted over here, that's our server. That's all it took to create a server. And now this over here is all it takes to run a server. We didn't have to set up any routes, we didn't have to do anything like that, but we do anyway so we can actually handle requests. Now we're going to be using the Express module, which we'll get from NPM, and it has to be saved to your package.json file every time you submit something. And we'll be using the Express module. We'll be generating an Express application, and we'll be sending that application to listen for requests. In our case, this is listening on port 3000 because that's just the argument we give it. Now we also run a function called config routes, and we pass it the application. So let's take a look at a couple things that we haven't seen yet. For one, this looks interesting because we're actually including a directory. Now, when you require a directory, you are going to require the index.js file inside of that directory. In our case, that index.js file returns a function rather, and this function takes an Express application and sets up several different routes. Now, Express runs on a series of middlewares, and what you have to know about these are that posts and users are both exporting something called routers. Now routers have, all the router does is it listens for a location, or rather it waits for a request to come in at a certain location, and after that it allows you to get information from the request in a callback and respond to that request accordingly. So as you see here, we use this app.use method and then we pass it /posts. Now what we're going to do here is we're going to take the Express app and we're going to say when we have a location that starts with /posts, we're going to use this post router, and this post router says, okay, when we're on /posts/id, or rather something that matches the syntax, I'll explain the syntax momentarily, perform this logic using the request object and the response object in a callback. So first thing you should notice, let's start at a simpler route. Let's look at router.getSlash. So in this case, because we're applying this router onto the entire /post path, all of these, every single time that we hit a route on this, it will be because it starts with /posts and then whatever this is. So if we went to, and let me run it right now, Yeah, that's because I didn't do anything. Now if we go to localhost 3000/posts, what's going to happen is we're going to see an array. Now, let's take a look. Now if you notice, we start off with /posts, and then we have a slash, which is kind of just the default. And it runs all the code inside of this function. And finally, after this promise hits the database and resolves, we use the response object. Now every route you make will follow the same format. You're going to say an HTTP verb, in our case get. Now every URL you navigate to directly will be a get call from a browser. Post calls are a little more complex, and we'll be seeing those extensively next week. And so there's this request and response object that's passed into the callback. The request contains a ton of data about the request that was made to the server. The response is your access point to send stuff back to the user. So in our case, we're going to use the rest.json method, which will take an object, convert it to JSON, and send some proper headers down to the user to say this message, this HTTP response is of a type application/JSON. So use it as if it was just data. And that's why it's pretty formatted and so on and so forth for my browser. Because it's just it knows how to interpret these JSON responses as just in a sort of JavaScript tree view. Now, that's all fine and dandy, but what if we wanted to send data in with our requests? Well, let's take one of these IDs and take a look. Now if you notice, we hit this breakpoint on this router call where the URL that we're matching is a colon and then an ID. Now this is called a request param. Now a param is just something like a parameter for an argument. It's just some form of data that's passed in with the request. In our case, because we named it colon ID, in JavaScript we can access the request.params.id field to get that ID that we requested. Now in our case, request.params.id is the ID we passed over here. So this URL is formatted as /post/some GUID. Now this request.params.id is that GUID. Now there's other ways we can do things. We can do request.query, and that would get data that's after a question mark. So if I did that, we'd get foo equals bar because I did post/ID and then a question mark foo equals bar. Now query strings are a way of passing data with a GET request. Query string is how you just say kind of variables in that way, because params are more for URL based things, such as just things that users would kind of copy paste that URL around for a resource. So like post/1 or post/some ID, user/fill, and so on and so forth. So usually it has a lot more to do with the representation of the data. Now, just like we did before, we're going to use the response.json on the post to send back to the user a single post. So as you could tell, those are fairly simple. They're very easy to use. All of these things, these router.getThis, router.getThat, router.postThat, are called routes. A route is just a location, is a definition of a location and what you do at that location for that HTTP verb. Now I briefly mentioned before that there's 4 types of verbs that we'll be using. The first is get, which signifies that we want to retrieve some sort of resource. The second is post. Post requests contain data that are not in the URL, but instead are also in things like the request body, which is a bunch of content that's sent with the request. Now GET requests don't have a body. However, post requests will, and we'll be able to serialize it next week into an object so that we can easily kind of work with that and create data. Now from an organizational standpoint, a very popular pattern is starting to crop up where we do it just like this. We have a routes folder that has an index.js file, and inside of this index.js file we're going to set up a function to be exported, and this function will take the Express app that we want to configure, set up all our routes by saying for every part of the path we're going to have, set up a new router and apply it to that part of the slash posts. That will make a little more sense when we get into middleware, because that's essentially what we're writing right now. And then finally we have this app.use star, which means everything else just send a 404, which means it's not found. Now inside of our posts.js, we require Express so that we can create a new router, and then we require our data modules. Our data module will not have changed at all. It's still following the same fundamentals that we started with. They're returning promises. They're just handling data and dealing with that stuff. And in our case, because all these request and response things are asynchronous, what we can do is we can go asynchronously get the post, resolve that promise, and then send JSON down later. Now, very often you'll be doing just this for the rest of the course. You'll be designing some API route. We'll get into rendering HTML soon, but for the most part what you'll be doing is you'll be just responding to requests and sending back some data about them. You'll notice that over here we catch for an error. In our case, we're just going to send a 404 status code, which will, using the send status, will close off the connection after sending 404, and it will state that nothing was found, and so that the entity didn't exist. Same thing holds for getting the whole listing, and for posting, it's not implemented, so we're sending a 501. Now users is very similar. It's essentially the same thing, just with users. Now, this index file will get included in our app.js file. Now, our app.js file will be where we create our Express application, which is our server. And so we'll make this, we'll configure that folder, which has the index.js, and we'll use that exported method on the Express application, and from that we will have successfully applied a bunch of routes onto our Express application. Now we can begin actually approaching those routes. Now all of this builds up to something very simple. We're building out our very first API. Now you might not be familiar with what an API is. An API is simply an application program interface, which just means it's a sort of contract of, here's how you can use my program by sending HTTP requests in this way. Now what that means is we make it so that our servers respond to requests, and because we're sending JSON, we kind of created a little REST API, they're called. In our case, we said when we go to posts/ID, where an ID is something we provide, we'll be sending back some data. Now, there's more than just retrieving data. Particularly next week, we'll be focusing a lot on creating and updating data as part of our API. So our first server is going to just read blog posts that I seeded. And from there, what it will do is it'll just allow us to get some basic information that's been seeded when we set up our database. And same thing with users, we'll be able to get users and so on the same way. Now you're going to have to do something called seeding your database, probably for the final project. Seeding your database is just a series of creating some fake data. Now in order to run this, you would have to type npm seed, or no, npm run seed rather, and that will automatically run the seed file. Now the seed has access, it's just a node file, it's just a node script, so we're going to use it to reformat our database and just start it off from now. So that's essentially the bulk of it's just starting for requests and responses, and that's really what an API is. So this, this was a very cut and dry one. Nothing really too interesting going on, but writing a server, the moral to take away from this one is that you're really starting to separate your concerns now. And by that I mean, there's not a single, if you notice, none of these routes have database calls, for example. And that's on purpose because we want to separate our concerns. We want our server to just focus on getting data and sending it to the user, figuring out what the user wants and giving it to them, but not necessarily figuring out what the user wants, setting up database calls, figuring out if an error occurred in the database, and blah, 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 and crunching big numbers and so on. No, we want it to be very separate. We want our web server to just deal with requests, response. So it takes a request, figures out what the user wants, pulls that data using our data module, and then just sends it back in a response. So that's a pattern that we're going to be growing and more into throughout the term now, but it's starting now. We're at a very large separation of concern, and which is really one of the most important parts of this. And that makes API design very easy. It makes it so that we'll be able to write very modular code, and it'll just be easier to program like this in the long run, because you'll be able to take out any part and fix it and change it as needed, and you'll also be able to just much more easily maintain your projects because, well, it's very small parts, and it's easier to fix a small part than a large part that's all jumbled up. So that being said, that's an introduction to web servers and Express and what's going on there. As usual, if you have any questions, feel free to let me know. Have a good night.